All right, last one, we want to talk about what happens to a wire in a magnetic field. So in this case, we're going to have a wire, and that segment will have a length L and carry a current I, okay? And we will put it in a magnetic field. We're going to ignore the rest of everything and just look at that magnetic field. So what's going to happen here is along the direction of the wire, as long as the current is perpendicular to the field, that's going to generate a force. That force will be, again, strangely, this direction. Okay? And we'll take that and we will use it to do more stuff in the next lecture. But this is basically how the forces come together. This is really interesting because what will happen is later on in the universe, if you have currents sitting around making their loops like this, you're going to be able to change this. So this will push these two wires apart. If they're going the same direction, they pull them together. And that'll be very interesting, right? So that's an interesting example that we don't do. They used to do that in classes. What they do is they'd put huge voltages over two thick wires, have a really burly guy come over, give him rubber gloves and stuff, thick rubber gloves, have him, and they'd put the current through, these wires would bend, and then this guy would have to try to pull them apart, and then he wouldn't be able to, even though it's soft copper wire, right? And the whole point is that this is a really strong effect when you actually get it running with a high current. So that was really dangerous, and they stopped letting people have fun like that for insurance purposes. So 3.3 is insurance ruins all the fun, right? Is that what it is? No, it's the force on a current carrying wire. It should be a long straight current carrying wire. Is proportional to the current, which makes sense, right? The current is actually what's reacting to the magnetic field, and length, which also makes sense, because the longer this wire is in the magnetic field, so it's how much wire is there inside of the magnetic field. The longer that wire is, the more force is pushing on it, right? I think that makes perfect sense, because there's more current. Each little bit of current here adds up. So if you have a longer bit or a longer piece of wire, there are more little bits of wire that are little bits of current in the wire that are reacting to the magnetic field. Okay. And then we have a right-hand rule again. I'll call that right-hand rule 4. And that has your index finger on the current. Strangely enough, the middle finger goes to the field, and the force is on the thumb. Okay. And we'll do this. F is equal to I, L, B. There we have another one, sine theta, and theta is this angle between the direction of the wire and the direction of the field. All right, simple enough. The same idea, right? This is your length of the wire. Like everything else, this is your current. We do the same thing over and over and over again. Okay. So that's what we get for this thing. So what I'm going to do is, in the example, I will take a little bit of wire like this, and do some stuff, put a current through it like that, going through it, right? And we'll see how much force that creates. All right. And then we're done with 10, going to 11, which will look at each one of these things we've talked about here and how it creates a field, right? So just like in electrostatics, everything that generates an electrostatic field reacts to an electrostatic field. Here, in magnetostatics, everything that generates a magnetic field reacts to a magnetic field, and vice versa. So that's just Newton's third law at work. So we'll look at that next time. After that, we'll look at some examples, basically some dynamic examples, because we're basically doing statics here. We're just calculating a force, and so these are all like Newton's second law things. Number 12 will be dynamics of particles and things in a magnetic environment. After that, we'll go on to electromagnetism. Magnetoelectronics is something totally different. It'll be fun to talk about, but it's beyond the scope of this class. And then we'll talk about optics. All right, so that's enough for today. I'll talk to you again on Wednesday. What day is this supposed to be? I don't know. Actually, I haven't calculated what day this is supposed to be yet. So, bye now.